let's go over kind of this first portion. All right, so this part of the training will cover the first part of designing a battery project, which is developing the usage profile for your use case. So we'll cover three main use cases, right? The first one, solar plus storage. So you have a battery facility that's getting tied to a solar facility. We're going to go over the scenario description, what this battery system is intended to do, and how it's intended to charge, how it's intended to discharge. All right. So the scenario description here. So we have an existing solar facility, and let's just call it Sacramento Solar, is constantly curtailing or clipping energy during the spring due to an interconnection limit of 8.25 megawatts, right? We seek to design a battery system to do the following. One, capture that energy that is getting wasted or curtailed by the inverters because of the interconnection limit. Store that in the battery when it is available, because it's not available every day, and discharge it later. So that way, you now have more energy production from the system, right? Because it has solar and it was getting curtailed. Now, when solar is not there, right? Because not every day, this is a what was it? A 10 megawatt solar facility, right? It's not every day that solar production exceeds that 8.25 megawatt mark, right? It's a certain number of days. So when that doesn't happen, what you're trying to do with your system is charge from the grid and discharge it during peak, which we're assuming here occurs 5 to 9 p.m. So we're assuming a summer peak here, right? This is actually very, very close to the way Duke has its current solar plus storage RFP, right? You got, I think, I don't know how this next year's one is going to look like, but 2023 RFP, you're charging from solar and discharging it later. Duke specified one cycle a day, right? So what happens when solar isn't producing? You probably want to charge from the grid and discharge later. All right, so now the first step, please pull up Storlytics. So first thing we're going to do, name the project. So generally, we want to start with the primary use case, which in this case is PV clipped energy capture, because we said, remember in the scenario description, we wanted to capture energy from the solar facility that's greater than the interconnection limit, which was 8.25 megawatts. So after naming the project, select the primary application, clipped energy storage. This is the app that allows you to charge based on a solar profile and also discharge based on a solar profile. So click, make sure that that is on, okay, and set it to priority mode. So now we go to dispatch parameters. We know the battery project, the limit we want to set for charging from solar is 8.25 megawatts, right? Let's go back to the scenario description here, right? We know the interconnection limit is 8.25 megawatts, right? So we can come here and set the charge threshold to 8250, right? Because it's in kilowatts here. So what I've just told the program is when the PV profile power is greater than 8.25 megawatts, charge whatever that delta is, okay? All right, now for the discharge, could have used this one and just told it, all right, whenever PV power is less than a discharge threshold here that I specify, start discharging. But I'm going to use the equalize daily discharge and charge energy feature to tell it to discharge later in the day. Let's just say 5, let's see here what we had here. All right, 5 to 11 p.m. All right. And we're assuming we're going to base this system on a lithium technology. So at a high level, let's just assume 85% round trip efficiency for them. The microgrid demand app has a plotter, so I'll just use that for simplicity for now. Let's see, I have to set a load here. I need a 365-day load. All right, and I'll just Sacramento Solar. Okay, it's not showing up here, but I'll use this one. All right, so this is just for an example, right? So this is solar. What you see in blue here, that's solar output, right? Okay. So let's just take these 2 days, right? So a lot of days you don't get this much solar. So let's get one where didn't get a lot of solar production. Man, sunny period. All right, here, for example, right? So we set it to discharge at to charge at 8 megawatts, right? So when solar production is greater than 8 megawatts, it's going to discharge this delta here, right? Now, for a day like this, right, because there's just not a lot of power greater than 8 megawatts, right? It's not gonna have as enough energy as it did here. So let's assume this is 9, right? Because this is what 15-minute resolution, right? So there's actually this is 8 to 12, right? So that's 4. So you have 16 data points here between here and here. So it's basically taking over the hour. Let's just talk hourly. Over the hour, it's taking the average power, right? And then since it's an hour, now you can consider that's energy. And yes, you can assume it's 1 megawatt hour, right? And then it takes that and discharges it over the 6-hour period, right? Now, the power is going to be 1 megawatt divided by 6, right? All right, so now we basically set everything we need. I'm going to turn this microgrid app off. We have everything we need to run the simulation, but the run button isn't on. So what we do here, we know that our PV profile is 15-minute resolution, right? Well, no one here knew that. I only knew that. So I know it's 15-minute resolution, but you can know that by opening the CSV file and seeing its resolution. So here, but we know it's 365 days. So we set 365, and for time step, select the 15-minute option. Right? And then set simulation and create templates. So now you see the run button is on, and you can run this case. Oh,
It's 1 hour. Yeah, right.
Okay, yes, it's a 1-hour resolution system. So change it to 1 hour, select 1 hour, set simulation. Now click run. All right, it did it. Okay, now you can save this project if you want. Let's just save it. Let's just call it SPS project 1. Right?
Did you just get file save up?
I did save, but either one of them will do it. If it doesn't automatically pull up the projects folder, go into the projects folder. Save it under projects. So Storlytics user files, projects. All right. So now click generate report. The button in the middle here. So it's going to take, depending on your processor, it's going to take about 30 seconds or 20 seconds to load. All right. So you should get a report that looks like this. Is that showing up for everyone? All right. Oh, there we go. So for me, it showed up. Yep. So it was produced. Now this report, it starts off with the inputs you had, you should see kind of, if you don't see it on your screen, refer here, right? So right now, the only use case we have or application we have is PV clipped energy storage. And we can see now kind of the sizing that that's resulting in, right? So maximum capacity, if you're looking at the table under PV clipped energy storage app, you see that charge maximum power was about 1100 kW. Maximum energy was 7.76 megawatt hours, right? So that's just charging only. Now, then here you see kind of the 24-hour layout. So it shows you kind of each month, kind of the level of PV output that was charged into the battery, right? And once we get here, right, into the time series, you can see here that in blue, what's in blue here, that's the solar, and our charge threshold is this purple line. So you can see here, kind of as the case described, in the spring, solar production is being curtailed, right? So hopefully with this battery we're putting or we're designing, you'll be able to capture that. All right, now let's shift to the daily energy charge, discharge, utilization app. Now here, Grant, to your question, now you see over a 24-hour period, over that period we said from 5 p.m. to 11 p.m., right? We're discharging different levels based on the month, right? So what this is doing is taking all the time series, making it a 24-hour period, and telling you the range over a 24-hour period of discharge. So in PVSys, if you chose the virtual array power column in the 8760, it would be the DC, right? So for this case, going back to the scenario description, right? And I should have stressed on this more, but we're planning to address this with an AC coupled battery system. So here, up here in the case description, due to an interconnection limit. So you have the inverter capacity to dispatch, but your power plant controller controls your inverters to basically get off of MPP. So instead of, in the existing system, the power plant controller is limiting output, but in the new system with the battery, you can just charge that into the battery, right? So not waste that energy. All right, great, right? And this next section here, right, tells you in detail. So these tables give you the maximum power and maximum energy, right? But when you get here into these histograms, so we have one for power and one for energy, this is where you really start getting an accurate idea of how to size the system in the battery system modeler, right? All right, so let's take the the month 2 plot. It's probably this one, right? So what it's doing, the bold part of it is the maximum for that month, right? The shaded area is what happened during that month, right? So now all right, let's talk about this one because it's easier. I think this is August, right? So this is telling you that, all right, for August, the maximum you got is represented by this bold line, right? But within the month, you had this shaded you had PowerPoints in that shaded area.
Okay.
Right? So it kind of gives you a general representation of what's happening daily over different months. Okay. Right?
Thank you.
Yeah, and it comes in really handy when you have like 8760 profiles, so you have 365 days. So let me show you something. Here, your time series starts to look like this, right? When you really can't see anything, right? So yeah. All right. Now, my favorite part, the histogram. So a lot of people kind of base the design of their systems based on the 100th percentile, the maximum, right? What's maximum load? 10 megawatt. All right, we need a 10 megawatt battery, right? What this chart is doing is it is telling you how often different power set points are occurring, right? So for the power histogram on the x-axis on the right, you have power. Okay. On the left, you also have power, but for charging. So right is discharge, left is charging, right? And you can see that up here, charge and discharge. So the blue kind of columns, that's your typical histogram, so buckets, right? It's telling you the number of points between different thresholds, right? The orange is what is called a cumulative distribution function, right? Easy way to read a CDF is, you look at a number, so let's just say 600 kW. So what's the percentage at 600 kW? We're at about 90%. So what that means is 600 kW represents the 90th percentile, right? So what I can deduce here, what I can tell is if I size my system at 400 kW, right, I can be covering, almost 90% of the points, right? So that's for discharge. Now for charge, right, it's kind of, you have you're not getting a lot of really what I would call diminishing returns, right? The more power you increase, the more kind of set points there are, right? So here, like if I'm at 1 megawatts, right, probably almost at 95% or so, right? So this tells me really a 1 megawatt system would be more than sufficient, capture more than 90% of the points, right? So for our use case here, right, I really care more about charging because I want to capture all that energy, right, from solar, right? So discharge, perhaps if discharging was calling for more power, I can maybe say, all right, how about I go back and increase the discharge period, right? So that would reduce the amount of power I need, right? So as you're kind of building your simulation and you're designing your project, you can prioritize different aspects based on your use case. Yeah. So what I'm trying to get at, what we can control for this project that we're trying to design is discharge, but charging is based on solar output, right? So that's why if I were designing this, I would give more weight to the charge piece for sizing in particular. All right. So, all right, now shifting to the energy histogram, right? Now, if we get to the energy histogram, right? Now, to be clear, the energy histogram, all it's doing is it's looking at the energy discharged daily and the energy charged daily, and it's telling you the percentile point and the distribution of each, right? So I can see here from this shape, right? The blue here, right, is that I have a lot of points that are that are at zero, right? Here, okay? I don't have a lot of points on kind of, at higher energy capacities, which makes sense because I know we're only clipping or curtailing solar during the spring and during the summer and winter. Remember, when we went through the report, right? Summer and winter, there wasn't really much going on, right? So it was only this period. So it makes sense that most points are here, right? It also makes sense that for the cumulative distribution function, the orange here, right? It starts out at about 80% or so. That means 80% of the days we're not discharging, right? Or charging, right? So what does that tell me? This battery system is extremely underutilized, right? Only some days during the year it's being used. The rest of the days it's we're not doing anything with it, right? So now that I know that, I know I can stack more applications. So then I can go back here and say, let's just look at our scenario description again, right? So charge from solar power that exceeds the interconnection limit and discharge that energy later. So we've done that. All right. Charge the best from the grid when solar PV is not available. So this is kind of the summer, the winter, all other seasons other than the spring. And discharge energy during daily high energy price periods, right? So we can now go back, right, and turn on schedule. And under schedule, right, we can say, all right, charge when, and we have it in priority mode. So what it's telling us here is that, all right, if clip energy storage is dispatching, prioritize that. If not, then execute schedule. So now I can set the schedule based on the sizing of that we deduced for the primary application, right? Which in this case, when we look through the histogram, right, we gleaned, yeah, a 1 megawatt system, 4 megawatt hours would be plenty. So here, 1 megawatt based on charge, again, more than 95%, right? And discharge, you're much more, right? You're almost 100%. Now, the 4 megawatt hours, where does that put us, right? Here, you're almost at 100%, and here, almost at 100% as well, right? So now we know, all right, we can say charge 1 megawatt, right? Let's just say at peak solar production period, right? Or lack thereof in this case, 10 a.m. to 2 p.m., because we're assuming that's going to be the cheapest period, right? And now for all months, execute this schedule. All right. We just added another application on top of it. All right. So we selected 1 megawatt here. All right. When we look at the charge part of the histogram, really there isn't significant diminishing returns, right? There is diminishing returns, but it's not that significant. So when you go from 800 kW, for example, to 1 megawatt, you're going from what looks like almost 90% or so to like 97%. So it's high enough to where you can do that. But at the end of the day, these are design choices, and every kind of one is different, right? So if you're constrained on your project, you can say, you know what, I'll suffice with just the 800 because, XYZ, right? So here, for example, let's just use the discharge as an example. Going from 400, going from 400 to 800, so doubling the capacity, only gets me about what looks like, I think, 5 to 10%. So doubling the capacity. But here, right, you're getting much more than 5 to 10% if you do the same thing, right? Here you're going from what, 60% to 800, you're going to 90%. So that's 30%, right? So yeah, the flatter it is, the higher the diminishing returns, the smaller your system. Like, you're not going to gain much by adding that capacity. All right, so now click run, right? So now we're running it with schedule as the second priority, right? Now click generate report. So this is the report after running both applications. So we have PV, clipped energy storage, as the number one priority, and schedule as the second priority, right? And now let's look at the profiles we have. Okay. So I'll just skip here to the full profile, right? So because this accounts for everything. Now, what is this telling me? Right? This is telling me that on days where there is solar, I'm getting kind of this kind of outer outline here, right? But if I don't have solar production, I'm charging my battery system here from the grid, right? And then I'm discharging it later. Now, since kind of there's a blank area here between kind of 0 and the smallest charge point, this means I'm doing this daily, right? Same thing for discharge. All right, it just loaded for me. It should look exactly the same. There we go. All right, so now let's look at the power histogram. All right, we see that here for charging, right? We set it up to charge at 1 megawatt, right? So now we see a jump here in the set points with 1 megawatts, right? So that's the schedule. And since we had it discharging over, I think it was what, 6 hours, right? You're gonna see here it's like 450 or 500 kW or so, right? So that's why this is the schedule app. All right, let's go to the energy histogram, right? Okay, so here, see that, remember the kind of the big jump here we had at 0, which was telling us, most of the points where we weren't doing anything, or most of the days we weren't doing anything with the battery. Now we see kind of a better distribution. We have a lot of days right around 3 megawatt hours being charged, a lot of days around 2 megawatts to 3 megawatt hours being discharged. Let me open up the slides here. All right. So what this is telling me is our system is now utilized much better.
So there are more events where the battery is engaged, whether it's in charging or discharging.
Correct. So it's now fairly utilized. All right. So kind of good to mention here, we're posing some applications as best capacity specific applications. In other words, you base your battery system's size on that application versus capacity dependent, which means you base the details of the application on the capacity you deduced previously. That's what we just did here, right? We ran PV clipped energy capture, right? And then we kind of came up with the 1 megawatt, 4 megawatt hour sizing, right? And then when we came to energy arbitrage, we said, all right, we're gonna assume charging at 1 megawatt for 4 hours, right? So one, we deduced the capacity. The other, we used the capacity we already deduced. Good. However, I wouldn't use the CSVs from the battery profile creator. I would wait till I simulate the system in the battery system modeler, because now, right, we can see that, all right, whatever we produce is going to be based on a specific battery system, right? Because we said we're going to do 1 megawatt, 4 megawatt hours, but that doesn't cover all the set points, right? So you want to account for that. You want to account for the losses, right? So yeah, you can do it with the CSVs, but after battery system. Good.